Uh, Today's class is based on the organization of the block structure languages and hashing. Indicates how you are organizing the various language constructs for the symbol table and other thing. This organization for block structure languages which refers to the symbol table. Now we are talking related to the topic. The block structure is what is the meaning of block structure? We know what is the meaning of block structures or blocks or block structures. Generally, the programming languages can be defined as structured programming languages or non-structured programming languages. Whenever we are referencing the structured programming languages, what is the meaning of say structured programming languages? Structured programming language it contains various control structures in order to process the statements in the form of simple statements, conditional statements, or loop control statements. Right. Similarly, we also know the block. What is the meaning of block? A set of statements. Okay, identified as a logical unit. Okay, so the block structure language is a kind of language in which sections of the source code is within some matching pair of delimiters. Okay, that means within the pair of closed and open and closed braces or begin and end statements based on the type of language. Okay, so some languages contains delimiters begin and end, like SQL, and some languages contains delimiters as open brace and closed brace. But whatever we are writing in between these two delimiters, we are calling this a block of statements. Okay. As part of some conditional statement or structure statement, we generally execute this block of statement until unless we are mentioning the exclusive terminating the particular block and going out of the block. Right. Such section get executed one unit or one procedure or one function. It may be controlled by some condition statements. The conditional statement can be if statement, while statement, do, while statement. Right. Normally, the block structure language supports structured programming approach. Wherever we are using the blocks of statements, generally this blocks of statements concept supports structured programming. So, for example, we are having the C, C++, Java, Pascal, Fortran, Lisp, Snowball. All these are structured programming languages. Now we will see what is the some non-structured programming languages also. Okay, the non-structured programming languages, say for example, it contains some other languages. It may be repeated. Okay, non-programming languages are Lisp, Fortran, and Snowball, where we are using there exclusively go-to statements in order to control the loops, where we identified here in the previous sections as part of the intermediate code using the go-to and the labels concept, right? Using go-to and label concept, right? So this is the meaning of structured programming. How we are implementing the symbol tables in the structured programming languages, we'll little bit elaborate today when compared to the last class. Each entry in the symbol table can be implemented as a record with several fields. Each entry in the symbol table can be implemented as a record with several fields. Okay. We are having the various data structures as we identified in the last class also. The various data structures used for organization of block structured programming languages are linear list, self-organization list, hashing, tree structures. Okay. We identified the format of the symbol table in the last class in relation with the format of the data structures. We are adding some more information. Okay, right. So the symbol table organization, first of all, we'll see linear list. Okay. Linear list means it can be implemented using array. Okay, and in the self-organization list means the linked list operations. In the linear list operation that we are showing as part in the small figure, where we are identifying it can be two-dimensional array or multi-dimensional array, where it will, we are identifying the name of the required variable, then it is associated with the number of attribute information. Okay, so linear list of records is the easiest way to implement the symbol table. In this method, array is used to store names and associated information. The new names are added to the symbol table in order they are arriving or in order they are scanning in the lexical analysis phase. The pointer available is maintained at the end of the stored records. To retrieve information, some name, we start from the beginning of the array and go on search up to the available pointer, up to the available pointer. If we reach a pointer available without finding a name, we get an error that is indicating use of undeclared names. That is the message we receive while we are compiling any program. Okay. While inserting a name, if you found any other variable with the same name, we need to ensure that the variable is already present, and we need to view the error message. Okay, because error handling routine also a parallel operation with all fetches the compiler. Okay, in such case, if the variable is already available, if the variable is already available, then we are declaring as multiple defined names or multiple declarations, or variable is already declared. Okay, what is the advantage of using such this organization is it takes minimum amount of space, additions are simple. Okay, and limitations is it requires higher access time. What is the limitation? It requires higher access time. Okay, right. Because so often it required. Similarly, we are having the one more organization. Okay, the other organization is called self-organized list. The other organization is called self-organized list. Okay, in the self-organized list, in this method, symbol table is implemented using the linked list. A link field is added to each record. A link field is added to the each record as the required format in the linked list organization. We set record in the order pointed by the link of link field. A pointer first is maintained to point to the first record of the symbol table. The reference to these names can be name 3, name 4, name 2, or anything. Okay, it can actually the link can be refer to anything, but in generally we represent the next field information. When the name is referred or created, it is moved to the front of the list, or we can adopt the different approaches. We can add at the end also. The most frequently referred names will be tend to be at the front of the list based on the way we are reading. Here what we are doing in addition with the creating a new node in the linked list, if some variables are referred frequently, that like a variable conditions inside a loop, because this condition will be executed every time. Such are the statements in the loop statements. Okay, the statements will be executed a number of times. Those will be added at the front of the list. Those will be added at the front of the list. Hence, access type to most frequently referenced name will be list. That is one of the other thing in organizing the subordered list. Okay, right. What is the advantage is using the linked list organization? It takes minimum amount of space. Additions are simple, but once again, when compared to the other organizations, it required a higher access time. Okay. What is the one more thing we added to this class? Whenever some names, some variables are referred more than once, whenever that variables are organized more than once, or repeatedly we are referencing, those names will be placed at the beginning of the list, okay, so that those variables will be retrieved fastly, okay, when compared to the other variables, right? But still, even when compared to the, it is better when compared to the previous array implementation, but it may be once again slow when compared to the reorganization or hash organizations. Right. Next, rules for the nested block structures we identify based on the various programming languages we'll try to refer here. Okay, a scope is the subsection of the program's text. Typically, we identify the role of a nested block structures where the variable is available, where the variable is not available, where we can refer, where we can't refer. Which can indicate we identify the scope information. Scope is the subset of the program's text, typically corresponding to a procedure, function, method, class, or a block of statements, Okay, an identifier can have only one definition in the given scope. Okay, in a given scope, a variable can have only one definition. We can't have multiple definitions. But at different scope levels, we can have the same name can be used for definition of the variables. Okay, so an identifier can be used in a scope as long as it is either defined in the scope or in a containing scope. Okay, it can be defined there or it is within the limits of the particular containing scope. Okay, sometimes forward references are not allowed. What is the meaning of forward references? Before using the particular variable, we need to declare the particular variable or function. Okay. Generally, we do the forward references at the beginning of the program. Later, we are using those names, the function names or variable names, somewhere in some other, maybe procedures, functions, or somewhere in the program. Okay. Some cases, the thing is, these forward references may not be available or allowed. Okay. In such case, we need to declare those variables within the particular block only. Okay. The basic thing is some programming languages may allow a nested blocks, a block inside a block. Some programming languages may not be allowed. Okay. So the example of the many programming languages allows arbitrary nesting of the scopes, a scope inside a scope, a block inside a block, like Pascal functions or procedures. In Java, inner classes. Okay, in the some machine languages, let constructs. Okay, any use of an identifier, refer to the declaration of the identifier. Occurs in the smallest enclosing scope. Okay, in the smallest enclosing scope. Generally, we refer that the particular any variable or the declarations in a smallest enclosing scope. Okay, than global scope. Okay, right. So textual nesting of scopes forms a tree. Okay, the nesting of scopes also forms even a tree structure also. that also we can identify. Okay, so we are identifying here a class definition skeleton illustrating the nesting declarations. Okay, say maybe class a program inside a program. That means we are creating a class. The class is inherited in the program. In the class, we can include one more subclasses. Okay, uh, like this. So it is the program is containing the variables and the class is the class once again containing variables. Okay, maybe the same variables once again here repeated. W is repeated here once again. Okay, that is it. Okay, the only thing is we need to identify when we are referencing inner W and when we are referencing the outer W. Okay, right. So, for example, considering the interpretation of identifier references in the program skeleton here, the tree of scope corresponding to the program test is shown in the figure, right? So, whenever we are referencing W within this class, we may use this W. If you are referencing this particular thing outside this particular class, then it may refer the outer W. Okay, we call it as a global variables and local variables. The only thing is we need to identify within the symbol table also when we are referencing the local variable and when we are referencing the global variable. Okay, right. Say for example that previous the table it is containing the program path, whereas here we are identifying a tree of scope corresponding to the previous figure. So the main containing the variables w, x, a, d, whereas in the function we are having one way we can use w, x, z, b, c, and in the function d, okay, or method d, we can use variable z. Okay, in the we can identify, okay, in the scope of the b block, okay, in the scope of b block we can refer x, in the scope of c we can refer x and y, in the scope of refer we can use x and y, okay, based on the local and because in the block B it is containing on the integer x, in the block void C, we can refer the x and y. Both are part of this. These two methods are part of the class A. Okay. So when you are referencing B, we can use some variables. When you are referencing the C, we can use some variables. When you are referencing A, we can use some other set of variables. Okay. That is the meaning of the scope of the organizations. In the organizational compiler symbol table, also we need to refer all these scope information. When we are referencing a variable through the symbol table tells us whether it is valid or not. So the organization of many compiler symbol table is fairly complex as a result of the need to support the scope rules associated with the block structures. Okay, so the block structure where we can refer, where we can't refer, everything need to be implemented in the symbol table. So to support all these scope resolutions, okay, the implementation of the symbol table is very somewhat complex. Okay, the standard approach to explaining the symbol table organization, however, adds additional complexity by failing to properly distinguish the role of the scanner in building the symbol table from that of the semantic analysis routines in completing it. Okay, so the thing is, in what way, where we are creating the symbol table, first we are starting with the scanning of the program, okay, by each and every token, and finally in the semantic analysis phase, we are also adding semantic rules or rules and conditions, various conditions after analyzing the routines and adding to the symbol table. Okay, right. So it becomes all these operations becomes complex. We need to implement all these things, right? So here the thing is, many compilers, okay, or text describe the symbol table as a dictionary or typically it can be implemented using a hash table or search tree also. Okay, the simple table is simply a collection of objects or structures. Okay, so if you are identifying particular thing based on the type information and containing the semantic rules of each in the symbol table, we can identify symbol table is a collection of objects or structures in which attributes of the identifiers are stored. Okay, right. Then uh, the one more type of the implementation, the hash table is simply can use, or it is a simply a mechanism that enables the scanner to associate symbol table entries with the characteristic form of identifiers in processes. Okay, based on the characteristic form of the strings, we are identifying the address of the particular location. Once the program has been transformed into the syntax tree, once the program has been transformed into the syntax tree, okay, each and every statement of the particular program has to be converted into the syntax tree. Then the semantic analyzer has direct access to the symbol table entries through pointers stored in the tree, through the pointers stored in the tree. First, what we are doing, we are identifying the various tokens during the lexical analysis phase. Then we are storing all those in the symbol table. During the syntax analysis phase, we are forming syntax tree to identify whether the statement is in the correct form or not. Then we are translating the control to the semantic analyzer, and it to directly access the symbol table entries because all the semantic rules and declarations, the type information, everything will be cached in a way that the first analytic phase of the particular program. Then we are attaching in the symbol table only. The symbol table only. Okay. The hash table used by the scanner is may not be needed here. Thus, it seems wrong to okay the hash table as if it were the symbol table. Okay, the symbol table we are already identified this particular thing. Okay, the examination point of this point is not necessary. Once again, right now we'll see the symbol table organization using the hash function. The symbol table function using the hash function. Once again, the we are organizing this particular thing. The hashing is an important technique used to search records of the symbol table. This method is superior to the list organization. Okay, as we know, the hashing means it can directly compute the address of a particular variable or a symbol or a token, like same. Okay, so that we can process fastly. In the hashing scheme, two tables are maintained. Likely to be, it is called as hash table and symbol table. Hash table contains hash function, the location in the symbol table. The symbol table, as usual, the various symbols and its related information. The hash table consists of the k entries 0 to k minus 1. These entries are basically pointers to the symbol table. These entries are basically pointers to the symbol tables. Okay, pointing to the names of the symbol table. To determine whether the name is in the symbol table or not, whatever the name we are referencing using the hash function, we use a hash function h such that the h generally we are mapping to the name of a particular variable will result an integer between 0 to k minus 1. The integer between 0 to k minus can be recognized as a bucket, okay, or various other types, okay. Principally, we can call it as the bucket, this 0 to k minus 1. We can search any name by position, okay. Using the position, we can obtain the exact location of the name in the symbol table. The hash table and symbol tables are looks in this particular fashion, okay. Right. The hash function should not be result in the uniform distribution of the names. It should be distributed, okay, based on the values. Okay, the hash function should be such that there are minimum number of collisions. Okay, we need to avoid the collision. That what is the meaning of collisions? If you are it is identifying all this resulting the conversion of the hash function into the address. If it is resulting to the same address for more number of variables, then it may lead to the collision. Nothing but the bucket is having more impact. It should be uniformly okay occupies all the buckets. The collation is a situation where a hash function is resulting in same location for storing the names. Okay, so we are having the various even collection resolution techniques, resolving techniques. It may be open addressing, chaining, or the caching. Okay, what is the advantage is quick search is possible. What is the limitation is okay. It implement is complicated little bit when compared to the linear. Okay, implementation is a little bit complex. Extra space is required for the hash bucket also. Okay, uh, obtaining the scope of variable is a little bit difficult because we don't know because the various maybe scope variables in the various scopes is occupying the same bucket. Various variables in various buckets are scopes are occupying the same bucket. So obtaining the scope of the variable is very difficult in this particular thing. We can easily look at, but obtaining the scope of the variable is difficult. Okay. In the symbol table, in the symbol table is a hash table view of a compiler detecting undeclared and multiple declared identifiers becomes a task. Okay, splitting between the scanner, parser, and symbol table routines. Okay, so the thing is, whenever the hash table is faster, but okay, whenever we are implementing the hash table for the purpose of the symbol table, detecting undeclared and multi-declared identifiers becomes a task to split between the scanner, parser, and because we are using the various hashing techniques. Okay, collision routines, वगैरह also. So it becomes okay a task, complex task between the scanner, parser, and symbol table routines. The symbol tables interface provides two functions: find and enter. The find takes the identifier name and returns either a pointer to the associated symbol table entry or error return code indicating that identifier was not found. Or whenever we want to insert anything or enter any variable identifier into the symbol table, takes the identifier name and either creates a new entry for the identifier and returns a pointer to it or rise an error if an entry is already existed. The syntax analyzer has to somehow tell the scanner whether it is currently processing a declaration or a use. Things get even worse if the block structure is involved whenever we are dealing with the hashing. Okay. A cleaner separation of the function can be arranged. Only one such function is needed. A function lookup with which takes an identifier such as for an associated entry and returns a pointer to the associated entry. The errors that would have been raised to find and enter can instead be recognized during the semantic analysis phase. Each symbol table entry would include a Boolean defined attribute. When the semantic routine processes a declaration, they would check to see if it has already been defined and raised an error if appropriate. Similarly, the use of undefined identifiers would cause an error also. Okay, so to move to the final slide, the basic idea is to let the syntactic analyzer simply process all the references to an identifier by mapping them into the pointer to the symbol table entry using the hashing function for the identifier. The semantic analysis phase then distinguishes the declarations from uses by either putting information into or taking information out of the symbol table entry. Either you are copying into the particular buckets, or we are retrieving the information from the bucket. Okay, this is the various ways we are implementing the block structures, programming languages, organization of the block languages. Okay, and the hashing function with reference to the symbol table. Okay, how we are implementing the hashing with reference to the symbol table. Similarly, how we are organizing the block